Hello everyone, my name is Neha Kardam and this is the third lecture on Introduction to Microprocessor. In this lecture, we are going to learn about the flowcharts. So let's get started. Flowchart, or another name for that is block diagram. It is a type of diagram that represents a workflow or a process, and it can be defined as a diagrammatic representation of an algorithm. So in the last lecture, if you remember, we covered the algorithm, which is a step-by-step approach of solving a task. And in the flowchart, it also shows the steps of any task, but in a boxes of various kinds. And these boxes are connected among them to indicate the flow of information and processing. And the process of drawing a flowchart for an algorithm is known as your flowcharting. Now we are going to start with this first block, which is oval in shape, and let's see what does it mean. So this oval block is basically used for the start or end of a program. So in the beginning, which means in the beginning and at the end of the program, you will use this oval shape box, and it also indicates the halt in a program's logic flow. So a pause and halt is generally used in a program logic under some error condition. So always remember this, you will be using in the beginning and at the end of your program. So, and let's see the another one. This is the rectangle box, and it is an internal operation to configure settings and move the content of memory or perform a mathematical operation. So this box represents arithmetic instructions. So all arithmetic processes such as adding, subtraction, multiplication, division are indicated by action or process symbol. So this port C is equals to output basically indicates one of the instruction, and right now just understand that this is a type of operation you want to execute in your program. So you will be using this in the flowchart for any arithmetic instruction. And then we have this diamond shape, which performs the logic test. So as you can see, is color equals to red? Yes or no? So if it is yes, then maybe leads to some other instruction, and if it is low, then leads to some other instruction based on your program sequence. So this diamond symbol is basically your decision point, and decision is operation based, such as yes and no, or true or false you can also use in this case. So this is another type of box which you use in the flowchart. Now let's see next. So next we have a parallelogram. So this parallelogram, it inputs or outputs the operation. So a parallelogram, it basically denotes any function of input or output types, and the program instructions that take input from input devices and display output on output devices are indicated with this parallelogram in a flowchart. So for example, we have used here write 0 cross F8 to port C. So this number basically represent in hexadecimal F and 8, and it is asking to write this number into some port C, which is basically, let's assume it's a register. So it wants this particular hexadecimal to move into the register. So if you have instruction like this, you will be using parallelogram. Okay. Now next is connectors. So this you might be using in some of the cases, but whatever the block diagrams, the boxes I discussed previously are the basic ones, and this one is used when flowchart becomes complex or it spreads out over more than one page. Then it is useful to use connectors to avoid any confusions. And as you can see, it is represented by this a circle. Now let's take an example of a flowchart. So you can see we have combined all the boxes which we saw previously except the circle one, and in the form of an algorithm. So you can see here, start the program. Port C is your output. It has defined this port C is something which is your output, and port A is your input. And read port A, so it's asking to read whatever is there in the port A, and that's why you use the parallelogram box. And then you have this diamond statement, a diamond box, in which you make your decision or you put up your question. So port A, does it have, so bit 1 of port A, so let's assume that port A has like has a 8-bit 8-bit register, and it is checking if the bit 1 is equals to 0 or not. So if it is 0, yes, then go to next instruction. If it is no, then go to maybe something other instructions. So you see that how we can use these 4 basic boxes in a flowchart, and each of them have their meaning. Now let's take an example of This question says draw a flowchart to input 2 numbers from user and display the largest of 2 numbers. So now at this point, I would request you to maybe pause the video and think about how you can make the block diagram for this particular question. And once you're done, unpause the video and check if your flowchart is matching with my flowchart. So I'm going to show you how the flowchart looks like for this particular question. So this is the flowchart. It has a start, which is a oval shaped box. So starting the program, and then we use the parallelogram box, and this is basically used to give the instruction input number 1 and then input number 2, and then here is the decision. So it is checking if the number 1 entered, is it greater, or is it greater than number 2 or not. So if it is true, then display number 1, and if it is false, then display number 2. Okay, and then further it is sent to this connector box, and then to the stop. So actually you can directly use a stop here. You don't have to use the connector here. Usually it is used in a complex flowchart, but just to show you like where we can use this circle in a flowchart, that's why I put it in this flowchart. So you understand that 2 numbers are entered, and then the comparison is made, and then statements are put up like whether it is true or false instead of true or false, or you can push yes or no. So if it is yes, then display number 1, otherwise this, and then stop the program. Now let's move on to the next slide. So this is a in-class exercise, and the purpose for this exercise is to learn how to use the flowchart or the block diagram. So what you'll be doing, the students will create a block diagram or a flowchart of a program for a student starting from sitting position to the open sitting in the chair to open the classroom door. So basically you'll be sitting on a chair somewhere in the classroom, and then one of the other students, they will basically write the program or in a flowchart form, and then the next step would be, once the block diagram is completed, then other student will basically behave as a student robo, and they will follow the instruction you made. So the purpose is that we are going to check if the student robot is able to understand your instructions, and student robot will only be following whatever is written in your flowchart. So student robot is not going to assume anything like as a human we assume. So the student robot is just going to follow the instructions. So we'll be doing this activity in the class, and these are the four basic blocks which we'll be using in creating the flowcharts. And you can see the instruction is given. So if you stand, then the operand will be up, sit will be down, walk forward, how many feet, rotate body right, how many degrees, rotate body left by how many degrees, extended right arm by how many degrees, and then open hand or close hand. So all these instructions you'll be using into this block diagram, and come up with a good idea and see how it works out. So this is the end of the lecture. Thank you so much for watching the lecture.